Good morning, children. Welcome to your chemistry online class. Today, we are going to discuss about a new thermodynamic term called entropy. What is entropy? Entropy is the measure of the disorder of a system. This term used to measure how much the system is disordered. What is the randomness of the system? For example, when a liquid turns into gas by heating it, the intermolecular forces decreases. We know we change liquid into gas, the intermolecular force between them decreases, the speed of the particle increases. Thus, particle become more disorder. That is, randomness of the particle increases. So, entropy of that system will be more. We introduce another thermodynamics term, that is entropy, that is denoted by the letter S. So higher the isolation, higher the entropy. Change in entropy accompanying a chemical reaction. If a chemical reaction done, there will be change in entropy. For example, if liquid to gas, the entropy increases. A crystalline solid will have the lowest entropy because how much is the systematic arrangement, the entropy will be less. Whereas the gaseous state having highest entropy. It is also state function like all other thermodynamic functions such as internal energy, enthalpy, etc. And it is also independent of path. Whenever heat is added to a system, its molecular lotions increases, causing randomness in system. This heat Q has a randomizing effect. When we heat applied to any system, the randomness increases. Thus, the temperature is a measure of the average kinetic motion of the particles in system. We'll see mathematical representation of entropy. When heat added to the system at lower temperature causes greater randomness than when the same quantity of heat added to it in the higher temperature. Therefore, entropy change is inversely proportional to the temperature, and therefore delta is equal to Q reversible by T. The total entropy change, that is delta is total, is the entropy of system plus entropy of surroundings. For a spontaneous process, we have to calculate and we have to take the sum of the system and surroundings. When a system is in equilibrium, the entropy is maximum. So the entropy change will be 0, but the entropy will be maximum. We can say that the entropy for a spontaneous process increases till it reaches its maximum, and at equilibrium the change in entropy is 0. Since entropy is a state property, we can calculate the entropy as a reversible process by the following formula. We'll find that both for reversible and irreversible expansion for an ideal gas, it is an under isothermal condition, that is delta U will be 0. So, but delta system plus surroundings is not equal to 0. Therefore, delta U does not discriminate between the reversible and irreversible process, whereas delta S does. Next term is Gibbs energy, that is denoted by the letter G. If you know how much will be the spontaneity of a process denoted by the letter Gibbs. If there is no increase nor decrease in the entropy of a system, can determine the spontaneity of the process. For this, we determine a new thermodynamic function called G. G is Gibbs free energy, which is given by the formula H minus Ts. Gibbs is an extensive property and a state function. Therefore, the change in the Gibbs energy for a system defined as follows. Delta G is equal to, that is delta Gibbs free energy of the system is equal to this. If we add delta to this equation, we'll get delta H minus T delta S minus S delta T. While simplifying, we can write the equation is delta G is equal to delta H minus T delta S. Thus, Gibbs energy change is equal to enthalpy change minus temperature into entropy change, and is therefore referred to Gibbs equation. Gibbs energy as a unit is equal to joule. In the system is in thermal equilibrium with the surroundings, then the temperature of the when the temperature of the surroundings is the same as that of the system. That is, also increase in enthalpy of the surroundings equal to decrease in the enthalpy of the system. So it is vice versa. If the system is in thermal equilibrium with the surroundings, then the temperature of the surrounding is the same as that of the system, because heat will transfer and it will equalize. Also, if enthalpy of surroundings is equal to decrease the enthalpy of the system. Therefore, entropy change in surroundings is equal to, that is noted by that delta S surroundings, which give us delta H surroundings by T, that is minus delta H surrounding system by T, that is opposite. Therefore, delta S total equal to delta S system plus minus H del system by temperature. Rearranging, we will get T delta S total is equal to T delta S system minus H system. For a spontaneous process, delta S total, that is total entropy, always greater than 0. So if we substitute, instead of this one we substitute here, we will get the value. Therefore we can also write minus delta G should be 0. So for a spontaneous process, the entropy and Gibbs free energy, the negative value of Gibbs free energy must be greater than 0. Then only we can say a process is a spontaneous process. Delta G is the net energy available to do useful work, and this is measure of do useful work and thus measure of free energy. We'll see the criteria and all in next class.